Welcome to Talkcast and to a live Talkcast, Science News and Ask Me Anything. And I decided to sit over, if you're watching this on YouTube, to sit over at the side on one side of the screen because I thought, oh, look, what I can do is do some science news and put some images up later on, for the people who watch this later. As it turns out, although YouTube Studio has a thing called a video editor, the video editor no longer has the capacity to add images. So that shouldn't matter too much because the overwhelming majority of people, of course, who are fans of Talkcast listen via audio. So apologies to the people on YouTube today because I'm going to be talking about science news and pretty pictures without the pretty pictures. I just don't have a facility to put them up. I kind of do. I mean, I have a screen, and that's what I might do in the future, but I didn't have time to organize that today. But for audio listeners, hey, I'm going to have to be descriptive, I suppose, of some things, because the first bit of science news I wanted to talk about was yet more images released by the James Webb Space Telescope. And this time, just a day ago, so we're talking on the 16th of March now, so the 15th of March, a star 30 times more massive than the sun is a variable star of a kind called a Wolf-Rayet star. And a Wolf-Rayet star is very close to the end of its life. And this star is about to go supernova. But of course, when you hear that term about to go supernova in astrophysics, think anywhere from now to millions of years away. We just don't know when the thing will explode. But because it is so massive, 30 times more massive than the sun, and unstable, the best explanations say that the thing will explode at some point. And the Wolf-Rayet star is characterized by sort of going nova, not supernova. Nova is when a star like the sun, typically, towards the end of its life, doesn't explode, expands out to a red giant, but then in the very final throes of death before it ends its life as a white dwarf, it releases its atmosphere, most of it, which collapses in onto the hot core and then suddenly expands out again, but not as an explosion. It just expands rapidly, increasing the brightness. And so that's called a nova, from the Greek for new star appeared in the sky. And so this is what this Wolf-Rayet star is doing at the moment. It's releasing lots and lots of gas from its atmosphere in sort of waves. And the James Webb Space Telescope has taken lovely pictures of this. And so you can go look that up. Just look up Wolf-Rayet star, Rayet, R-A-Y-E-T, and wolf just like the wolf, the animal. And this picture is spectacular. It's a spectacular, pretty pink picture of this star near the end of its life, absolutely dwarfed by the nebula of gas that now surrounds it. So this is one of the latest images released by the James Webb Space Telescope. These things seem to be dribbling out now and again. The James Webb Space Telescope, of course, does a lot of things, much of which isn't pretty pictures, a lot of which is detecting spectra and that kind of thing. And those don't look all that impressive. But now and again, it'll take a very impressive picture, which has to be computer enhanced and that kind of thing, because it's an infrared telescope anyway. People always worry about that. Are they lying to us when they color enhance these things? Well, you have to. If you take a picture in the X-ray part of the spectrum, you have to enhance it. Otherwise, people wouldn't be able to see it. Or it'll appear just as a black and white kind of thing. Okay, so that's James Webb and the latest news from there. Some more science news. And this was just yesterday as well. Also on the theme of astronomy, the headline is, this is a Forbes article, Venus is volcanically active right now, say scientists using 32-year-old images. Now, we should expect, as a matter of geology, that Venus would be volcanically active. It's approximately the same diameter as Earth, the same mass as Earth. We would expect that, obviously, the atmosphere is entirely different, but the geology should be similar. And the reason the geology should be similar in many respects is because geology is largely driven by the heat of the core. The heat of the core, as the heat left over from when the solar system formed, plus the radioactivity of the decay of radioactive substances that are there in the core. Why are these radioactive substances there in the core at a higher concentration than what they are at the surface? Well, remember, all planets started out as liquid rock because it was so hot. And liquids being liquids, the densest thing falls to the bottom. And the densest thing on the periodic table, uranium, among other things, are the radioactive stuff. And so they coalesce at the core. That's where you have a high concentration of these things. So I have to dig deep into the ground, typically speaking, to get hold of these dense materials, because much of it is sunk towards the bottom. Why didn't they all sink? Because of chemistry. The uranium was able to react chemically with some other materials to form certain ores like pitch blende. And so therefore, some of that stuff is near the surface. Lucky for us, so then we can have nuclear reactors and the whole nuclear science industry and all that kind of thing. But anyway, in the case of Venus, we would expect it's going to be similar to Earth in terms of its core. It's going to have a very hot core, a solid inner core because of the pressure, solid, and the outer core would be liquid rock effectively, but mixture of metals and other things, high in radioactivity, cooling down over time, but which would provide energy to the mantle, the thing outside the core that is a kind of matter that isn't quite liquid and not quite solid. They usually refer to it as plastic. So it does flow. It can kind of bend, and now and again, when the pressure is just right, you can have the part of it liquefy, and then it can erupt via fancy geology, which was one of the things that makes geology fascinating. So you would expect to have continental drift on Venus. You'd expect the surface, the crust, not to be one just solid bit like an egg, but rather like a cracked egg, where the bits, the continents, float around on top of the mantle, which is, again, plastic and more dense. The crust is low density. And so it's there up at the top. The crust is completely solid. Of course it is. But the mantle is hot. And now and again, you get these regions where part of it can liquefy. When it liquefies, that's what we call magma. And then it can erupt out of volcanoes and it becomes lava when it gets to the surface. And so they're saying that they've reanalyzed some pictures. And so they've got some pretty pictures there of the surface of Venus from a long time ago. But they've reanalyzed them. They're saying, well, these things are actually active. These volcanoes that we took pictures of are actually active. Let's read through the article. Researchers have found evidence of active volcanism on the surface of Venus for the first time. Although the closest planet to Earth is known to have prominent volcanic features, it's unknown whether its geologically young surface is down to ancient or ongoing volcanic activity. I would say, well, the best hypothesis is that being similar to Earth, it would have current day, active geology. The new evidence comes from a manual search of radar images from NASA's Magellan spacecraft, the first spacecraft to image the entire surface of Venus, which orbited the planet from 1990 to 1994. Magellan was the first planetary spacecraft launched from a space shuttle in 1989. The images, which have only been available in high resolution in recent years, stop short of revealing an exploding volcano, but show a 1 square mile vent that changes shape over 8 months. There you go. There's your smoking gun. The research was published today in Science, which was 2 days ago. We're looking at 14th of March. That's evidence of a lava flow emanating from the vent, say the researchers, which obviously indicates ongoing volcanic activity on Venus. The volcanic vent is part of the larger Mart Mons volcano system, a huge shield volcano that rises 3 miles above the surrounding plains. So we should not only expect it to be volcanically active, geologically active, the volcanoes to be erupting, we would expect more of them. I mean, Venus is hot. just by the fact that it's closer to the sun. It's got this atmosphere. And so therefore, the heat which on Earth escapes more readily from the core of our planet out through the mantle to the crust and then off into outer space. That process would be significantly slowed down by the extremely hot atmosphere that is retaining so much more heat. It's got this blanket over the top, insulating Venus from its the cold environment of space. So its hot core would be hotter than ours, one would guess. They go on to say, the estimates of how often eruptions might occur on Venus have been speculative, ranging from several large eruptions per year to one such eruption every several or even tens of years, said Robert Herrick, a professor of University of Alaska Fairbanks Geophysical Institute. He said, we can now say Venus is presently volcanically active in the sense that there are at least a few eruptions per year. So there we go. It's great news for the two upcoming missions to Venus, Da Vinci Plus and Veritas, both of which will launch between 2028 and 2030. So we have some missions to Venus coming up. Venus is interesting for astronomers, but certainly not for anyone who's interested in life elsewhere in the universe, because it is an exceedingly hostile place. You're looking at around about 400 degrees Celsius there on the surface of the planet, air pressure 90 times that of Earth, where it rains sulfuric acid. So, you step outside of your spacesuit if you were to travel there, and you'd be promptly corroded, crushed, and cooked. Not a friendly place to go and have a holiday. So the Da Vinci probe heading there, and it's called Da Vinci because that stands for Deep Atmosphere Venus Investigation of Noble Gases, Chemistry and Imaging Plus. And that will analyze Venus's atmosphere to understand how it formed and evolved and determine whether Venus ever had an ocean. Yeah, perhaps. I mean, it would be remarkable. But perhaps it did have liquid water in the past via mechanisms I don't understand. And then the thing boiled away. Who knows why? My guess is that it never had any such ocean. That it always formed too close to the sun. It was always too hot there. It would have been bombarded, as we were, by comets at some point in its history from the Oort cloud, delivering water, but that water would have immediately vaporized, almost immediately vaporized. My conjecture is it's always hot, but I'm not an expert in these things. These people are. So we await what they have to say about it. The other probe that's heading there is called Veritas, and that stands for Venus Emissivity, Radar Science, INSAR, Topography, and Spectroscopy. It'll be the first mission to study the Venusian surface since Magellan. It will orbit the planet and peer through the obscuring clouds with a powerful radar system. It will create a 3D global map using radar, use a near-infrared spectrometer to see what the surface is made of, and measure the planet's gravitational field to determine the structure of the planet's interior. We can expect that the upcoming Venus missions will observe new volcanic flows that have occurred since Magellan ended 3 decades ago. We should see some activity occurring while two upcoming orbital missions are correcting images, said Professor Herrick, the geologist. So there we go. We've got missions to Venus coming up over the next few years. Final piece of science news for now is that I like this one because here we have talk of extinctions where they admit it's not climate change or the action of people that's doing it, at least not obviously. The headline is, a skin-eating fungal plague is silently tearing through wildlife across Africa, scientists warn. Silently tearing. It'd be more frightening if this fungal plague was making noises that did so. So yeah, it's silently tearing through wildlife. All right, so the headline is, a lethal skin-eating fungus has been spreading rapidly across African wildlife since the turn of the century, scientists warned Wednesday, shedding light on an unnoticed amphibian plague that has driven more species to extinction or near extinction than any other pathogen, and now risks wiping out even more across the African continent. Okay, so the amphibians are being wiped out by a plague in Africa. That's not good, presumably. Yeah, it's always hard to say in these things. Should we do something about this? Should we stop the plague? Is it necessary to have evolutionary pressures? Would people getting involved cause things to happen that are worse than what the outcome of the plague would be? We don't understand evolution entirely. We always talk about trying to prevent the extinction of creatures as if it's a bad thing, but it is also the thing that's always gone on. But is saying that it's always gone on the naturalistic fallacy of a kind? You know, that just because extinctions in the past have occurred, that we should allow them to continue in the future. Would that be a naturalistic fallacy? I don't know. I don't think we know enough about evolution to say. And so what the article, I'm skipping the details of the article, but they do go on to say, quote, amphibians matter more than most people realize, and losing them could have major consequences. Foremost, amphibians are keystone species in many ecosystems, meaning their loss can dramatically change the environment for the worse. These downstream consequences can have a big impact, such as driving malaria cases up dramatically, as therefore fewer frogs keep mosquitoes in check. Biodiversity is an important driver of innovation, notably medicine. And the more species that are lost, the fewer opportunities we have to learn from them. For example, salamanders, which possess the remarkable ability to regrow tissues, organs, or even limbs, are being studied with a view to unlocking new ways of treating serious wounds. Well, yes, okay, but I don't, I don't think we have to worry about researchers running out of salamanders. I'm sure we can keep a few, you know, on ice, so to speak, or in the water, so to speak, to do research on how it is they're able to regrow their limbs and organs, which would be a useful thing to know. We want to know that. We want to know why certain species never seem to show evidence of cancer, like sharks, apparently. Doesn't matter how old the shark gets, whenever they capture them, they never find ones with cancer. Perhaps because it's a selection effect. Perhaps only the ones that don't have cancer are the ones that you catch later on in life. The early ones that you catch haven't developed cancer. The ones that do develop cancer die either quickly from it, or perhaps other sharks, with the wonderful smell that they have, know if a fellow shark has a tumor or has cancer, and they eat it, taking it out of any possibility of being captured. But, you know, this is the theory, that sharks simply don't have tumors, they don't get cancer, and we study them in order to find out, is there something we can learn here? Is there something genetic we can do? You know, insert some shark genes into us somehow and therefore never get cancer. And can we insert some salamander genes into people of the future and have the remarkable ability to regrow tissues, organs, or even limbs? That would be good. Okay. That does my science news for today. Except maybe we'll mention one more thing. This is sort of the intersection of science and other stuff, philosophy, which is an article in Forbes also. The Chat GPT debate. Are we intelligent enough to understand intelligence? And I'm not going to read the whole article, just to say it's written by a neuroscientist. And I broadly agree with what he says and what the people he interviews says, namely that Chat GPT-4 shows zero indication that it's understanding things in the way that we understand things. El Diablo, I can see your chat, yes. Can you hear me? Is the question. Hopefully. Yeah, so far it's been going well this week. I've had experiences other times where I've been talking for a few minutes and I haven't been heard, but I think I figured out what went wrong. Yeah, and so the Forbes people, certainly this article was one of the ones that was a more sober take on ChatGPT-4. They were talking to at least some people involved in cognitive science, neuroscience, that kind of thing. I didn't see any amongst the people they were interviewing philosophers as such. But it is one of those areas where people discussing ChatGPT 4, the experts that people go to are the wrong kind of experts. And so you end up with the wrong kind of opinions, I would say. For example, people ask physicists this question. I have very little. There needs to be something that the specific physicist you're talking to has said that would indicate that they're worth listening to on topics outside of physics before I grant them, before I grant them the notion that they're going to be worth listening to on anything outside of physics. They have to say something. They have to demonstrate first that they're philosophically sophisticated. They have a broad understanding rather than a narrow one. They've read widely. They've engaged with certain ideas. But just because you're a physicist doesn't grant you any special insight into any other area. People have this idea that, that if you study physics, it's often physics, okay, that somehow or other that does something to your brain. That if you do really well at physics, that somehow that physics knowledge affects all the other things you think about in a way that it sharpens them up, and so that all of your opinions are therefore more valuable than someone else's. And it's just not true. I can tell you there's nothing in a physics degree that gives you any special insight into anything outside of physics. I've been astonished at times with how ignorant certain people with physics degrees are of simply chemistry, the next nearest subject, but they are. Understandably, some of them hate organic chemistry. So it astonishes me why people will go to a physicist whose bachelor's was in physics, maybe they got a master's in physics, they did a PhD in physics, and they become a physics professor, and then they're interviewed about philosophy and morality and whether ChatGPT is intelligent or conscious and whatever. Now, never mind physics. Computer scientists, similarly. Sometimes a computer scientist has a sophisticated understanding of the significance of things like universality, let's say. That's better. That could be broader. But yeah, my point here is that my heuristic is look at their oeuvre, their back catalogue of stuff. You read David Deutsch's book and you realize, okay, here's a person where I would like to go to him if there's a question about some system like ChatGPT 7 as to whether or not this thing is understanding stuff. That's the person I want to, because he studied epistemology. He's understanding the significance of computer science and what computation can say and how what explanation is. A preeminent expert on explanation and therefore understanding. He just so happens to be a physicist, and that doesn't hurt what he's saying. It enhances it. But the physics enhances the philosophical knowledge, which enhances the physics, and it's this wonderful kind of coherent worldview that comes together. And there are some other people like this as well. I'm not saying David Deutsch is the Lone Ranger in this. I think he's probably the preeminent example, the exemplar. But any random physicist or any random philosopher or any random neuroscience, not necessarily. You don't get any special insight by studying, becoming really good at one particular thing. We know this on most other topics. If you are the world's greatest cardiologist, well, you're the world's greatest cardiologist. We're not going to go to you for neurosurgery, brain surgery. We're not going to go to you necessarily for, even for, by the way, nutritional advice. Well, I find that, again, a selection effect. People say, oh, the cardiologists, they know about nutrition because after all, they're seeing all these people with heart problems, and a lot of these people who've got heart problems have had let's pick a thing. I know this isn't true, but, they ate a lot of fried food, so therefore they don't eat fried food. Well, again, that could be a selection effect. Perhaps that's statistics. You could give 100 people fried food throughout their lives. 50 of them will develop heart disease. They're the ones that the cardiologist see. The cardiologist doesn't see the other 50 that don't. So is it the fried food that causes heart disease in people? Some people, but not everyone. It's not an all or nothing thing. So yeah. So anyway, this article here, just concludes in line with broadly what I think about GPT-4, which is a wonderful thing. It's amazing. I mean, it's giving me far better answers, but it's still it's still refusing to say it doesn't know things. The esoteric question I asked GPT 3.5, ChatGPT 3.5, the previous version, was I asked it, what was the role of the Vichy police force, or the police force in Vichy, France, the civilian police force in Vichy, France during World War II, with respect to Nazi soldiers committing crimes? Are there any examples of civilian police officers in Vichy, France, arresting Nazi soldiers for petty or serious crimes like assault or robbery, let's say? Rather than say, so ChatGPT, rather than just say, I have no data on this, or I don't know, it said there probably were no instances of Vichy police arresting Nazi soldiers, which is not what I asked. I don't care about whether probably or not. I want to know. And if you don't know and you don't have a source, then that's fine. I know the arguments already. I know that it would be astonishing if that happened. I'd love to know an actual case. What were, to get an insight into how was, once the Germans were in charge of France, how was regular policing done? How was regular crime looked after? And what if the occupying German forces committed crime? Was it the military police? Did the civilian police have anything to do with this? Okay. I don't know of any documents, and I've looked and looked and looked. Okay. Googled and all this sort of stuff. So I thought ChatGPT. But ChatGPT, rather than just come up with and say up front, look, there's no data on this, it says there probably weren't. Why say that? Well, you don't need to say that. There doesn't need to be a statement of confidence about this. Just say, my training data didn't include any examples of this. That's it. That would satisfy me. And I think that's a better way to go. It should admit when it doesn't know something. But, oh well. All right. So I'm going to go to questions now firstly from Patreon. So there's a long Patreon question here. I'm going to have to kind of cut this short today because I have something to do at 3. So let me get through these quickly. It's going to be rapid fire now. Well, this first question is quite wordy. Nonetheless, it's the Patreon. So respect our patrons here. And RJ has asked, firstly, it's a story. So bear with us for the preamble. Hey, Brett, I was in a debate the other day with a friend who says he was reading The Fabric of Reality and can't take Deutsch seriously in chapter 10 on the nature of mathematics after he said, quote, thanks to Gödel, we know that there will never be a fixed method of determining whether a mathematical proposition is true any more than there is a fixed way of determining whether a scientific theory is true, end quote. I've read this chapter many times and I believe the person I was talking to misinterpreted the entire chapter. But he went on to send an email to Deutsch that included this, quote, the FAS Gödel evaluated was based on the system Russell and Whitehead designed in Principia Mathematica, and he proved that the content of the mathematics cannot be reduced to a PM like FAS, but this does not mean we lack a fixed method of determining whether a mathematical proposition is true. If, for example, you allow complete induction to be applied to quantified expressions, then you can readily prove a statement in a classical number theory that would be undecidable in a PM like FAS. Of course, a PM like FAS does not contain an axiom of complete induction on quantified expressions, so it is not surprising that it cannot capture all the theorems of classical number theory. End quote. Okay, so the question is basically, what is my take on that? Firstly, Gödel's incompleteness theorem was, it was a response. So the person you're responding to, it seems to be laboring under some misconception about, what it was doing. It is not the case that the Principia Mathematica was authored by Russell and Whitehead, among other things, to try and find a foundational basis for all of mathematics. So axioms across geometry, algebra, calculus, etc., arithmetic. And to say once you had all these axioms, you'd have the complete set of axioms, and then you could prove anything from this complete set of axioms. In theory, being able to program some computer mechanically to be able to just spit out the answer to your question. This was shown to be false because of what Gödel did. The project, the underlying project of Principia Mathematica, was shown to not be possible because Gödel looked at the axioms for arithmetic. They didn't have anything to do with Principia Mathematica. It was Peano's axioms of arithmetic that he used to show they were incomplete. Incomplete meaning you could write down a true statement, true proposition, which had no proof within that system. That's the incompleteness. Now, remember, for Gödel's PhD thesis, he proved the completeness of predicate logic. So first order logic, you can show that it is complete, and predicate logic. Predicate logic is that logic which contains the operators for all and there exist. And Gödel was able to show that this logic system was sound and complete. Sound meant beginning with the axioms, you could never prove a contradiction. You would always prove things true within that system, given the axioms. Things that were just as true as the premises. Your conclusions would be just as true as the premises. That's soundness, as long as you had a valid proof. Completeness said that all things that you could write down that were true in the system would have proofs. That's complete. So Gödel showed that for anything as sophisticated as simple arithmetic, that you would always have incomplete stuff. And so you could always add axioms. You could always come up with a new system of mathematics. And that is why David says there will never be a fixed method of determining whether a mathematical proposition is true, any more than there's a fixed way of determining whether scientific theory is true. This also goes to the fact that to prove something true would mean finally, once and for all, without possibility of ever having the possibility of there being an error, which is physically impossible. There is no such method. There is no such perfect method. In the privacy of our own minds, we make blunders and mistakes. Our brains are physical objects doing the computing. They can make mistakes. The laws of physics say that when you write down symbols on a piece of paper, it is possible, however unlikely, it is possible that those symbols can change. The laws of quantum mechanics. That is what we understand the laws of quantum mechanics to be. So therefore, any proof you do that appears to you to be valid and appears to you to prove something true could in fact contain an error. Fallibilism is always and everywhere governing proof, as it governs scientific explanation. So you can't get to this final certain truth. So your friend is wrong. There is no fixed method for getting to the truth. And by the way, there's always going to be new ways of doing mathematics. You can always improve stuff. Find a new route, a new way of proving things. But the central point is we are fallible. All proofs are computations. Computations require a computer. A computer is made out of matter. Matter obeys physical laws. The physical laws mandate the possibility of error and never allow you to completely ensure that you can have perfection at the end of any computation. Error can creep in always. You can't rule it out. Ergo, you can't prove things absolutely once and for all finally true. The best you can say is this is the best explanation I have. That's c squared equals a squared plus b squared. Here's my proof. My proof is a computation. I see nothing better. I see no way in which this thing could be false, except that I'm fallible. But until such time as someone points out how it's false, I accept that c squared equals a squared plus b squared, and for the rest of mathematical knowledge, and for the rest of scientific knowledge. I accept that this is the explanation. This is the best idea. It hasn't been refuted. That's the way knowledge works. but that's not to say it's impossible for it to be refuted, which is what it would take in order to say that something is absolutely true, finally true. So that's the first Patreon question. The second Patreon question is, hi Brett, I read Beginning of Infinity first with lots of help from your podcast, and I'm currently halfway through Fabric of Reality, again getting lots of help from you. I do not have a background in most of the topics being covered other than computer science. So as a relative layperson, I am wondering if you could highlight or talk about how David's thinking evolved between his first book and the second. I have read or seem to remember either yourself or David talking about things he would have written differently if he wrote them now. I guess another way to say it would be to ask you if there is anything in the Fabric of Reality that I should watch out for that is incorrect, that David or others have since corrected. Okay. Yes, the best place to go to find this out is to purchase the Fabric of Reality audiobook. And at the beginning of the Fabric of Reality audiobook, David Deutsch has new content. It goes for a few minutes answering that precise question. What's changed over the last few years since the Fabric of Reality was produced, written? Three things. One, just to summarize. One, David says he used the word justify or justification more liberally than what he would have liked to. What he meant by justification was that you're justified in using a particular rule, that you're justified in relying upon the science given the best explanation. It doesn't mean that something is justified true. That's not what he meant. That's not what he means by justification. If something is justified, it means, well, you're right to use this thing. Okay, you want to have a GPS system. You're justified in using general relativity in order to, find the location of things. That's a justification. Okay, so that's the first thing. He would change that, however. He would slightly alter the language or at least clarify that. So that's to watch out for. Watch out for the use of the word justification. The second thing is that at the end of the book, he talks about certain cosmological models which have since been refuted. There will be no big crunch, and so there's no point worrying about what Tipler's big crunch thing was all about. So that's the second thing. What's the third thing? I've forgotten now. So we've got justification. I've forgotten now. If there's something else that he would have written differently now. I just can't remember. I apologize. But they're certainly two important things anyway. The use of the word justification at the end. Watch out for the stuff on cosmology, which has actually been refuted. Okay. If I remember that, I'll come back to it. Mo Issy commented on your post. Hey, Brett, I was curious how we should think about abortion in regards to our best theories of what a person is. Oh, going in for the and more lighthearted, what is your favorite flavor of ice cream? Trying to get me cancelled here. I think I'm just pretty standard on the ice cream thing. I think I'm just going to go chocolate. Is that boring? Otherwise, blueberry. These days, there's just so many flavors to choose. It seems like everyone who goes on those MasterChef shows has a new way of making sorbet or ice cream that has a really weird flavor. But the first question, how should we think about abortion in regards to our best theories of what a person is? So my theory of this is that there comes a point where the fetus has a brain which can conjecture. And once it has a brain that can conjecture, I say it can suffer. Now we've got the problem of, well, how much can it suffer and all sorts of things like that. I would say that there's absolutely no controversy in the first term of having an abortion because the zygote, a single cell, the blastocyst, the multiple cells that form the sphere that are undifferentiated, throughout that first trimester, I would say that living thing, because it's not about whether it's living or not, it's living, is not conscious, not capable of having an experience, and therefore is not to be regarded as a person with the rights of a person. All right. The other person who has strong opinions on this is Yaron Brook, who basically says, look, no person has to claim on the life of another person. But he doesn't get into the difficult part of, well, what about a day before birth? I think that the conclusion of his, but I don't want to speak with him, but if you say that in the context of abortion, then you're saying that you can have an abortion up until the moment of birth. Like what, a minute before, rather than just giving birth? So there's something magical, therefore, about the cervix there, that once you've passed through the birth canal, then you are magically conferred with independent personhood on your own. But moments before you didn't, you aren't granted personhood. I think that's irrational. That doesn't make sense to me. I don't see anything special about those few moments. It's a Sorites problem. A Sorites problem is, when do you say a person is bald? If I pluck one hair out, am I bald? Of course not. 50, 1,000. There comes a point where if you've got one hair on your head, the average person would say you're bald. 2 hairs on your head, yeah, you're still bald. 3 hairs, you're still bald. Not completely bald, but we're just using the word bald, right? So there's no black and white line that we can draw. We don't know yet. When we have a good theory of consciousness, not there yet. When we understand AGI, not there yet, then we'll also understand personhood at the level of babies as well. So that's, that would be my suggestion there. We don't know when personhood begins. We should err on the side of caution. But certainly within that first trimester, I don't see an issue. I don't see an issue. We have, I think, one more from Patreon. No. Okay. I'm going to Twitter now and to questions for this particular live stream. So on Twitter, people have asked, and I need to move quickly again here now. Tybalt asked, were you familiar with Naval's ideas around leverage, happiness, etc., before discussing with him about the beginning of infinity and the fabric of reality? And I did respond on Twitter to this. I said, yeah, I watched and listened to his Joe Rogan and Tim Ferriss appearances, among other things, for example. So I already saw Naval, as everyone would have, just about, on Twitter. As when I had one of the big accounts early on when I joined. So he would come up, and of course, we had similar interests, I think. And so now and again, I would see him tweeting people that were interesting, tweeting. It would just come across my feed. People would retweet him. That would come across my feed, but I didn't know, who this person was. It's sort of very mysterious. The icon he uses for the image on Twitter is this mysterious person. Even the name sounded mysterious to me. Naval. What is this? And he first contacted me. Well, tweeted me during COVID, where I wrote some blog posts about the reaction to COVID, and I was critical of the authoritarian response in certain places and what I saw as overreach early on. Other people would disagree. They would say we needed an abundance of caution and people are being too cavalier about certain viruses and that kind of thing. Okay, that's a reasonable debate to have. But anyway, I had my views. They haven't changed much. But anyway, Naval quite liked it. I think he said I was being he wasn't as sanguine as I was, I think, at that time. But that was the first kind of interaction that we had. So that was the very beginning of COVID. And then over time, I was astonished. That he was this fellow that I gradually began to learn about. Okay, so very successful entrepreneur. And he was a fan of my podcast. Remarkable, But then again, of course, I'm in this amazing position of doing this podcast initially just for myself and about the work of David Deutsch. And David Deutsch himself retweets me now and again. It's an astonishing position to be in. Never before in the history of people has quite this situation arisen. Quite this situation arisen. It's as if you're a person of a certain era. Let's say I don't know what to compare it to, really. You're a young singer hoping to be a good singer, and you're putting out musical numbers, and Madonna says, you're a great singer, or Britney Spears, or Taylor Swift these days, of course, becomes a fan of your music. That's the kind of thing that when David Deutsch retweets me, that's the sense I get. This is amazing. And so then Naval was in that same sort of category. It's like, well, wow, this is cool. That someone would be interested like that. So once I found that he was a fan, and then therefore we had these shared interests, and I became very curious about looking him up. I was certainly a fan of Joe Rogan's, but I possibly did hear him on Joe Rogan, and I remember because he said stuff about AI automation and the welfare state and that kind of thing. Universal basic income, in particular. Universal basic income was something I'd written about, and when I heard Naval talk about it on Joe Rogan, I thought, here we are, like-minded. I'm very like-minded with this person. And then I started listening to as many of his appearances as I could, and realized, this is a person who we think the same way on a whole bunch of things. So, of course, given that, even independent of being fans of David Deutsch, we already agreed on a whole bunch of things, it seemed to me. And so, given that commonality, of course, we're going to agree on The Beginning of Infinity and the Fabric of Reality being the most astonishing books of the last, I want to say, century, perhaps all time. Yeah. Well, you can kind of say that because they both build upon, don't they, excellent books that have gone before. Yeah. Tybalt has asked, I'm curious if you've adopted any idea in your life or thinking, not that it matters necessarily where an idea come from. Yeah. The most important idea I think I have taken on from Naval is just being more kind about deadlines. Naval is very, obviously, famously, he is an outsider who managed to accomplish great things by not being an authoritarian overlord, even though he is the boss of lots of stuff, lots of things, ostensibly. Owner and shareholder and investor and all this sort of stuff. But gives the people running the various things freedom to work and to create. And so this is something in my life that, I think he's taught me, is to kind of relax about trying to get, because when I was a teacher, of course, you have deadlines to meet. You've got to be up at a certain time. Everything is highly scheduled. This is the truth of almost all jobs. But working with Naval is not like that. And so I've had to take that on. I've had to unlearn what I learned. I learned a specific kind of discipline. And now I have a different, certainly a different approach to doing things. And I am more productive as a result, and more creative, I think, as a result, by not setting particular standards that I need to meet, which is something I was, taught by well-meaning people throughout my life. Set goals. Set yourself goals. Of course, don't you want to have a goal in life? That you're striving towards? No. And this is where David and Naval sort of, have this meeting of minds, even though they use different language. It's about having fun and making the most of your life. And by doing that, you achieve what other people achieve when they talk about goals. The other people are setting fixed in stone this particular thing. But you can get more than that done by relinquishing the idea of a goal and instead striving to have fun, solving problems, and realizing that when you're working towards a solution, something better might come along, and it's not a bad thing to swap lanes and to do that other thing. Whereas the goal-oriented person over there says they're not going to be distracted. They are doggedly going to pursue this thing until they get it, no matter what. Nothing's going to get in my way, that kind of thing, that kind of attitude. And over here, saying it's not that other things might get in your way, but something might present itself that is objectively better, and you better keep your eyes open for that objectively better opportunity. And Naval also has this idea of playing long-term games with long-term people, which I think is also a fantastic philosophy of life, figuring out the people that are going to work with you in a way that allows everyone to thrive, you and them. Okay, we'll move on to the next question. Jitan has said, Sean Carroll has said the laws governing everyday life are completely known and that new successor laws to GR and CM will only apply to very small scales and very large scales. What do you think? I also answered this one and I said, well, he's just wrong about that. You know, everywhere is a beginning of infinity, really. Everywhere contains unknown stuff. People work in research in areas where there are open problems, but everywhere can be an open problem. We can always ask more kind of stuff about anything. Doesn't matter what the object is, what the thing is in reality. Siddhat Sangkavi asks, struggle between thought processes and David Deutsch and Eastern philosophy of being at peace. I've read The Beginning of Infinity and also Krishnamurti and venturing into Buddhism and going back to Papa. A lot of people say this. A lot of people say that there are so many echoes of Eastern wisdom in the books of David Deutsch, especially The Beginning of Infinity. And absolutely, this idea that you never have an unproblematic state, but you're moving from better problem to better problem. And that peace can be found in simply solving your problem over time. And I think this is what ancient wisdom says. Life doesn't need to be constant suffering. Suffering itself is just a problem to be solved. Tybalt has asked, any favorite books on the Enlightenment? I hope historians pick up on Deutsch's tradition of criticism idea and study it further, especially what brought it about for so long. Are you aware of ideas from Deutsch picked up by historians? I'm not aware. But my favorite books on, one book on the Enlightenment, which I don't think sold very well, but deserves to be better known, is Inventing Freedom by Daniel Hannan. I don't know if that's coming up very well. Inventing Freedom by Daniel Hannan. And that's absolutely brilliant. And so I got that in paperback. I think I got it in paperback because it's not available on Kindle. So that's how the Westminster system, the Magna Carta, leading through to modern democracy in Britain, contained ideas and laid the foundations for the possibility of rapid progress and peace and stability and all that sort of stuff. The other one, of course, famously, the other book on the Enlightenment is called The Creation of the Modern World by Roy Porter, which is well worth having a look at if you're interested in stuff on the Enlightenment. They're the two main ones that I've read beyond The Beginning of Infinity. Jitan has asked, great physics question from Jitan. He says, I've always wondered something about redshift. I understand the explanation when explained as the stretching of the wave as space expands, but what is going on at the level of the photon? How does an individual photon carrying an amount of energy that we call blue change into a photon that we see as red, i.e. carrying a different, less amount of energy? What happens to the photon's energy? Where does it go? Aha. Okay. There are, what you're talking about, Jitin, is the expansion of space due to the Big Bang, and therefore photons become redshifted over time. Where does the energy go? Well, you have to consider, when we talk about conservation of energy, we talk about an isolated system. An isolated system has energy conserved in it. If the system's not isolated, then the energy can get in and leak out. So if you're talking about the universe is expanding and these photons are being emitted from distant galaxies, which are redshifted due to the expansion of space, you have to consider where all the energy in the universe is and what it's doing. And what's happening there is the potential energy of gravitation is being exchanged with kinetic energy, and you're getting this reduction in the amount of energy in the photons. If you do the calculations for all of the energy in the universe, then there is no problem here. That's one issue. The other issue is somewhat related to what I'm about to talk about, which is not the same process, but you can get this in your mind. If you look at stars within the Milky Way, some of the stars are moving away from the solar system. From our perspective here on Earth, there's motions everywhere. Some of the stars appear to be moving towards us, some are moving away. Okay, the ones that are moving away, their light appears to be redshifted. So they emit the light, let's say in the blue to make it simple, and when it gets to us, it's in the red. Energy's been lost. Where's the energy gone? Aha, here's the problem. And this is also related to the cosmological redshift version as well. That's not an isolated system. From the perspective of the star emitting the light, it's emitting the blue photons. Those photons never cease to be blue. Never cease to be blue. They go out, they're blue. Everywhere they go, they're blue. Only for the observer on the Earth, because of relative motion between the star and the Earth, do the people on Earth receive red. And they always appear red. You can't talk about the emission and the observation of the photons simultaneously as if you're talking about the one frame of reference, which encapsulates where the law of conservation of energy would apply. Hopefully that helps. That's the other factor. Okay. Next question. A couple of questions on YouTube, and then I will call it a day. Hopefully I got to everyone's. Oh, I've got to. Yeah. Okay. So on YouTube here, El Diablo, you're our Britney Spears, Brett, really. P. Taylor, why didn't Sam Harris get it like Naval did? I don't know. I was listening to Sam had an interview that went for 4.5 hours or something with Lex Fridman. And I've only listened to the very beginnings of it. And yeah, there's a different conjectural knowledge is a tough thing. And in a sense, I think that sometimes conjectural knowledge is the whole story when it comes to this. And if you don't get that, then it affects what you think people are and what people are capable of. You know, Sam talks about, for example, the people who vote for Trump as if they're incapable of understanding certain things, as if in some way they're not, that because they're not seeing the world in the way he does, that therefore they're closed to a part of reality that he is seeing clearly. And I think that this is the distinction between the idea of knowledge as being justified and even though he might deny it, a bucket theory where you take on the true ideas and you're entitled to become more confident over time, versus everyone has infinite ignorance, and what we're doing is conjecturing explanations which capture partial truths about an objective world. This is not to say that some people can't be objectively wrong. Of course they can. But this vision of conjectural knowledge gives you an increased amount of compassion and understanding for people who stand in stark contrast to you, because you understand that on many issues, you are them. You are wrong fundamentally about things, because there's no royal road to truth and no method of being correct. So we should all expect in certain places to be completely wrong. And in fact, about everything, error abounds. And you should never be overly confident, feel a sense of being justified, because that way lies tyranny, as Popper would talk about it. The doctrine that the truth is manifest leads to tyranny. Yeah, and so that's what I think that is my diagnosis of many people who don't get David Deutsch. It's about that conjectural knowledge thing, because that runs deep. That runs the idea that you can have a solution to a problem that's final and not improve stuff. And when you do that, even if you're an anti-dogmatist, you can become dogmatic about that, about the whole idea that you are so anti-dogma that you can't possibly have your brain polluted by bad ideas because you've eviscerated bad ideas from your mind, something like that. Yeah. So I think that's it. I've gone through our questions. Thank you for the people who have contributed on YouTube today as well. That's great. Until tomorrow, in fact, because I'm doing one of these each day this week. Whether or not I can keep up that that level of intensity next week will be another thing. Tomorrow we'll do something different again. Today was science news and lots of really interesting questions. Thanks everyone. Thanks everyone in the chat. See you tomorrow.